Today we are going to discuss about how to determine transfer function from the state space model. So last videos I have explained about state space model representation by using different canonical forms. You can say physical variables, phase variables and canonical forms. Now from those canonical, that is a state space representation or state space model, how to determine the transfer function. No, this is the standard form of state model. So state equation x dot equal to ax plus bu for linear time invariant systems, output equal to cx plus du, where a, b, c, d are matrices. System A is a system matrix, B is input matrix, C is output matrix, and D is a transition matrix or direct transmission matrix. And U is the input, Y is the output, and X is the state vector. Okay. For finding the transfer function, you know the conditions. First you need to apply the Laplace transform and then use the initial conditions as 0 and find the ratio, right? So same way only you are finding here. First apply the Laplace transform to the first expression, that is the state equation. You will get here s into x of s minus x of 0, because here you are taking as initial conditions are 0. That's why x of 0 is equal to 0. We are neglecting here. That is equal to u into x of s plus b into u of s. For the second expression, when you are applying Laplace transform, y of s equal to c into x of s plus d into u of s. Okay, so equation number 1, 2. Now, from the equation 1, so this is x of s, this is also x of s. Just take it in one side. So, x of s into I unity matrix. So, or identity matrix Si minus A into x of s equal to b into u of s. Okay, x of s equal to this inverse. When you are taking this side, Si minus A inverse into b into u of s. Substitute this expression in the expression 2, this one here, right, output expression. So, y of s equal to c into this value you have to substitute here. So, Si minus A inverse into b into u of s plus d into u of s. So, u of s common for both. Just take it outside it, u of s. C into Si minus A inverse into b plus d into u of s. Where, what is the transfer function? Y by u, y of s by u of s. That is equal to, so remaining term, that is c into Si minus A inverse into b plus d. So this is the expression for the transfer function from the state model. If you know the matrices A, B, C, D, we can find the transfer function for the given state model. Okay. Next we will see how we will find out with one example. Okay. So find the transfer function for the state model. Here it is given x dot equal to ax plus bu, right? And y equal to cx plus du. D means here 0. Okay. So in the given state model, this is the state equation and this is the output equation. It's combinedly it is called state model. So how to find the transfer function? So y by u, y of s by u of s equal to c into Si minus A inverse into b plus. So from this state model, this is the matrix A, because you need to compare with the standard equations, state equation and output equation. X dot equal to ax plus b. So A is this one and b. Similarly, y equal to cx, right here. So from this expression you have to find out. First, because this is the inverse, just find out Si minus A. What is Si minus A? A is this one, S into I, identity matrix, minus A matrix, 0, 1, minus 3, minus 2. So S minus 0, this one right? 0 minus 1, again it is 0 minus of minus plus 3, and s minus of minus 2 plus 2. Okay, this is si minus c. So inverse of this we need to. So C, this is the matrix 1 0 row matrix, and then 2 by 2 this matrix, this inverse into B. B is a 0 2 plus D is a 0 in this statement. Okay, just to find out inverse, because it is a 2 by 2, very simple. That's why you can find out very easily. It is like A, B, C, D. Inverse of that, right? What you will get here? Find out determinant. So 1 over AD, S into S plus 2 minus of minus plus 3. This is determinant into, here you will get a D, that is S plus 2, here minus B, minus of minus plus 1, here minus C, minus 3, here it is C, right? Very simple. So remaining it is same, C is same and this one. Now you multiply with this and then multiply with this. Or because this factor you can take it outside and finally you can find out. Now you see here what you will get. This one we are keeping same. It is a row matrix. Just you find out here 1 into S plus 2 plus 0 into minus 3. So you will get S plus 2, and this one 1 into 1 plus 0, right? Again here what you will get, S plus 2 into 0, 0 plus 2. So you will get numerator only 2, 2 by S square plus 2S plus 3. So this is a required transfer function for the given state model. In this way you can find the state model. Okay, it is a very simple, just substituting the values, matrices of the given state model. Okay, even if it is 3 by 3, same way only you have to. Only thing is here you need to find out the inverse of that, Si minus C. Okay, remaining it is a multiplication only. You know how to find the multiplication. If you are taking this the first row and then column in this way. Okay, next we will see solution of state equation. Okay, here we are taking both homogeneous equation and non-homogeneous equation. We know already state equation x dot equal to ax plus bu, or x dot of t equal to ax of t plus bu u of t, right? If input is 0, that is u is equal to 0, then that expression it is called homogeneous expression. Whatever the solution you are getting, if input is 0, that solution it is called homogeneous solution. Okay, now we are taking directly non-homogeneous equation. So if you are finding that one, it is a mixing of both, right? So first term you will get, from that you will get 0 input response and 0 state response. 0 input response is nothing but homogeneous equation solution. Okay, now you see here x dot minus ax equal to b into u, right? What you have to take, just both sides, left hand side and right hand side, multiplied by e power minus at. This side as well as that side. Why you are taken? For our convenience only. Just you see here, if you are multiplying e power minus at into x dot minus e power minus at into ax. Okay, so this one it is equivalent to this only. Just you see here, reverse. Just you observe that d by dt of e power minus at into x, or x of t. What you will get, it is a UV method, right? First you keep this side once. So e power minus at into dx by dt. That is the first term. Plus, what you will get, second one. So keep x same, it is x d by dt of e power minus at. What you will get, e power minus at into minus a, right? You will get these two terms. That's why we are multiplying here this. So that is equal to right hand side. It is same, e power minus at into b into u. Okay. Now integrating both the terms, that is the left and right hand side term. So between the interval 0 to t. Okay. Now integration of derivation of this one. What you will get, integration and derivative. These two cancel out. The terms you will get here, this one. So what are the terms here? E power minus at into x of t at 0 to t. So higher value is t minus lower value. So e power minus at into x of t minus e power a into 0. What is that value? E power 1. X of 0. That is this. Equal to integral 0 to t e power minus a tau into b into u of tau into d tau, where tau is a dummy variable. Okay. Now multiplying both sides by e power at. So here you have taken both sides multiplied by e power minus at. Again you are taking reverse. Simply again same thing only, e power at. What you will get here? So when you are multiplying this one, or you can say shift this side also, both are same only. Okay. If you are multiplying throughout by e power at, these two cancel, x of t. That is, this term here you will get that side because it is a minus, this side it is plus e power at into x of 0 plus integral 0 to t e power a into t, this term. Okay. Minus a into e power a tau into b into u of tau d tau. Okay. So same it is, you can represent x of t equal to this one, it is phi of t into x of 0 plus integral phi of t minus tau into b into u of tau d tau. Okay. So here first term it is a 0 input response. If input is 0, you will get the response this one only. So this expression x of t is equal to e power at into x of 0. This is the solution for homogeneous equation. If input is 0 here, only this expression it is called homogeneous equation. For this solution is this one. X of t equal to e power at into x of 0. For the non-homogeneous equation, that is the entire state equation, this is the solution. Where phi of t is nothing but e power a. So that is called state transition matrix. Okay. That is called state transition. So this is the entire solution of state equation. Okay. In the next video, I will explain about solution, how to determine solution of state equation with an example.